Thank you for watching this video. So on this video we're going to talk about the status of rigid body with a question. So we are trying understanding the status of rigid body using this example. So let's go on with the question. So a crate of mass 80 kg is held in the position shown. Determine A, the moment produced by the weight W of the crate about E. B, the smallest force applied at B that creates a moment equal magnitude and opposite sense about E. And C, the magnitude, sense, and point of application on the point of the crate of the smallest vertical force that creates a moment of equal magnitude and opposite sense. So how do you go about with this question? Now, the crate has a weight acting in the center. So we need to find the weight of this crate. This is done by you knowing the value, that is 9.81 meters per second squared, multiplied by the mass of the crate to get the whole weight of the crate. So let's see that. So here we have 80 kilogram times 9.81 meters per second squared. So that will give you the weight is equal to 784.8 Newton. So now we know the weight. Now they say we are finding the moment and we are creating it at E. So this is the point E. So now this force, we can use the principle of transmissibility. This force can move down here and this will be the arrow. Now it means that the force will move through a distance this to get to E. So we need to find that distance. That distance was not given to us, but we know that from E to D it was 0.85 meters, and they gave you from A to the W, which is the weight, is 0.6 meters. So for us to get this distance, we are going to subtract 0.6 meters from 0.85 meters, which will give you 0.25 meters. So now creating the moment at E. So we try creating a moment at E. So creating a moment at E, we are going to get 784.8 Newton times the distance, which is 0.25 meters, which will give you a moment of 196 Newton meter. So now we know the moment which crate, or the moment that's produced by the weight about E. So now we are moving on to the second question, that is the smallest force. When you talk about the smallest force, note this: with the smallest force, it have the longest distance. So smallest forces have longest distance. So when they ask you to find the smallest force when the moment is given, you need to look at the diagram or look at the crate and make sure you find the longest distance given for you to find the smallest force. So let's go. Now the question is asking us to find the smallest force applied at B. So the smallest force applied at B, so we're going to get the force here that creates a moment of equal magnitude and opposite sense about E. So we are supposed to find the smallest force at B. Now we have the moment, but how do you get the distance? Now the distance is, I once told you that with the smallest force it has the longest distance. So we are going to find the longest distance, and from E to D, this is the longest distance, as you can see. So it is moving from here to this side. So this is the longest distance. So we are trying finding this longest distance. When you get that longest distance, we get a moment, we can find the smallest force. So let's start. Let's continue. So with this, we have BD using the principle Pythagorean Theorem. You can do this. That is BD squared plus DE squared will give you BE squared. So you know this squared plus this squared will give you that squared, which will give you, we know the distance from BD is 0.5 meters squared plus the distance from this side is 0.85 meters squared. So we're going to get the distance, that is the longest distance, to be 0.9861 meters. You can leave it in 4 decimal place. So now we try finding the force as we know the longer distance. So as you know that moment is equal to force times the perpendicular distance. We know the moment, we know the distance, we can now find the force. So we get in the force. The force is 198.76 Newton. That is the force. Yes. So the smallest force applied at B that creates a moment of equal magnitude and opposite sense about E is 198.76 Newton. So now we need to find the sense, and the sense is the angle. So we know we are finding this angle. That means with the longest distance. So we are finding this angle, and you can use any of the trigonometric ratio, which is sine, cos, tan, but I prefer you using tan. So we find tan theta is equals to the opposite over adjacent, and you know that the opposite is this angle is opposite to this angle and is adjacent to this angle. So the answer for the sense for this force will be 59.5 degrees. You can approximately leave it in 60 degrees. So now we are done with A and B. Let's go to C. With C, they are asking us to find the magnitude, the sense, and the point of application of the bottom of the crate of the smallest vertical force that creates a moment of equal magnitude and opposite sense about E. So there's a vertical force here, and we are trying to find that vertical force, but it's the smallest vertical force. So we are going to apply this principle with the smallest vertical force. It has the longest distance. So we are finding this smallest vertical force, and it is a vertical force, so it's moving upward. So what you need to do is now we need to find the longest distance. So the longest distance is from A to E here, this side. So we try using Pythagorean theorem to find that. Now you know that you have AC to be 0.5 meters, but we don't have EC or EC or CE. So we are trying to find the EC or CE. Now you know this distance is 0.25 meters, and this distance, how do you find that? You are going to subtract this distance from 0.6 meters and get this distance. So let's go. So with a smaller vertical force that creates the same moment, so you are going to use the same moment which is created at E. So we know that using the Pythagorean theorem, you are going to know that AC squared plus EC squared will give you AE squared, and you know that AC squared is 0.5 meters, and CE squared will be 0.35 meters. As you know, this is 0.25, so we are going to subtract that from 0.6 meters, which will give you AE to be 0.6103 meters. So now you know the AE. Now what you need to find is you are now finding the force. So you know this formula, which is moment is equal to what? The force times its perpendicular distance. You know the distance here, we know the moment, so we can try finding the smallest vertical force, which will be the moment over the distance, which will give you 321.3 Newton. So that is the smallest force. After they ask us to find the sine, so this one, the angle will be here. Using tan, you can still do that, which is opposite over adjacent. So you can do tan theta is equal to 0.35 meters over 0.50 meters, which will give you tan theta, or theta being equal to 35 degrees. So this is how to solve. So with this, you need to bring analysis and note that with the smallest force, it will have the longest distance, and with the largest force or the biggest force, it will have the smallest distance. Thank you very much for watching this video. Please subscribe, share.